Okay. We are back working. Yay! No issues this time. Okay. Oh, I don't text. Okay. So, did you have a chance to either A, look over what we did, or uh, figure out what you want to do next? Anything of that sort? The next weeks you have graphs, linear equations, quadratic functions, etc. So if the like, I don't want to go into that too much yet. If there's other things we should cover first. Also, did you check Discord so that you received the pages? Okay. I sent you 3 pages in the Discord in the private chat. Yep. Should have been 4 messages. Um they should be there. I don't know if you have to like click on something different for your thing, but it shows on mine that all all 3 pages have been. But that's okay for now. We can resend them. Yeah, don't worry about any of those details. Okay. So I want to look at ah, yes. Makes sense. Okay. Let's see. So we're now going to go on to linear equations or thing, quadratic, polynomials, composition. The vending machine. Okay. So the vending machine was a bit interesting. So a vending machine has 3 buttons. A, B, and C. If you press A, you get your fertilizer. I was actually trying to look up this problem because it can be reworded and have different outcomes and still be the same. Let's. It's just weird in terms of what you are going through. You press B, you get a pet rat. If you press C, you get either randomly get fertilizer or a pet rat. Now, the only thing that I don't see is what are the odds? Now, if they are equally likely, then it doesn't matter, right? So you want to know, like, which button gets pressed the most and which button gets pressed the least. Honestly, the way I would think about it, not a conventional universe. This might be. Hmm. Give me a minute here. I want to think about something and I want to look up something. I think, honestly, the way I would think this is just a description problem of how you would think. Because I'm not really, like. With people is the name. Bachelor's Community Public Health. Okay, okay. The only thing, like, you have enough money for one option. 4 years is only 4,000. Yeah, that is really affordable. Holy cow. Yeah, this is not a very conventional problem. You only have enough for one option? Honestly, besides this question, the rest of the class shouldn't be an issue. This question is just a bit weird because, like, there's not enough details if you want to think statistically. And so then I'm thinking that really this question is just about kind of writing down your own logic. Why would you one thing else? Yeah, exactly. So like if we kind of reason through the logic, we could be like, okay, um, if they are equally likely, so in C, if equally likely, then it doesn't matter, right? Then it's the same as picking one or the other, it's just random. If one is more likely than the other, then you're more likely to just pick what you want, right? So if the first case, you would press them all the same. If the second case, so like A is more likely than B for C, then you would probably just do A. In three, the third case, if C is not equally likely and B is more likely than A, then you'll probably just B. Yeah. No idea. This actually, I bet you if you Google this as like a Coke machine problem, so like Coke or Pepsi, and then the third option gives you either, it might even have the same. Do that real quick because it makes sense. Soda machine, Coke, Pepsi, and surprise. Yeah, yeah, yeah. Okay. So I think I found something that'll help us. So taste the can that you get by hitting the button with this. Let's say it's Coke. This means Coke. Cannot be Pepsi Poison because it never gives a Coke. Fries button. Pepsi, but the wrong. It cannot be Pepsi. It's similar but not quite the same. So this problem I found has where the labels are mixed up. I think the purpose of this question is just for you to explain your reasoning. I don't think there is a right or a wrong answer in this problem. I really do think it's just your reasoning. Depends which, I would say, like, it depends what you want the most. I'd break it up into cases being like, if you want them the same, you'll take either. If you want one more than the other, you'll take this button, this button. That's what I would do for this problem. I don't know if it would be right, but that's what I would do. Because honestly, it's not really a math. Okay. I want to look and see. I want to test you in a couple things. If you don't mind, I just want to know if you like can understand and do these numbers because it'll come in handy for just like basic algebra stuff. um do you know what this symbol means? Yeah, you could set up a chart of probability, I guess. But it doesn't, like, it would make sense if there was a probability for either one. In this case, I would just write if fertilizer is more likely, or any of those. If then, that's what I would write. So going back, do you know what this symbol means? Perfect. So when you say absolute value, I want to know, do you know what the absolute value of -3 is? Now this will be slightly slower because we will be kind of going through a little bit of a test stuff, but it'll make sense. So absolute value of -3. And this will delay. Hey, holy cow. Nope, no comma 0. It's just -3. So -3. What's the absolute value of -3? So this is a good thing for us to go through. So the absolute value, you know what it's called, but what does it do? So the absolute value is basically saying it returns the distance. So if we have like a number line and here's 0, here's 3, and here's -3, the absolute value returns the distance from 0 to that number. So if this is 3, the absolute value of 3 is 3 because it goes 1, 2, 3 units. The absolute value of -3 is like saying, how far away is -3 from 0? So it'll be 1, 2, 3. With that in mind, we can make the definition of the absolute value function. So here's the absolute value of x, which returns two things. It's either going to be just regular x, whatever that number is, if it's positive. So if it's already a positive number, if x is greater than 0, then it's just going to give you x. Or it's going to return the negative of x if x is already negative. For example, absolute value of -3 is the negative of -3, since -3 is less than 0. The negative of -3 is 3. So are we okay on this definition? to be absolutely fair, like this is the important. I wonder why you have such a delay. It's odd, but okay. So let me know when you're ready to continue, or if you have any questions about. So since since absolute value returns a distance, right? Like an actual distance from whatever number it is to 0, and we are at -3. -3 is how many numbers or units away from 0. Yeah, so like this number itself is already negative, and since it's less than 0, we're going to take the negative of that to make it positive, right? The absolute value returns distance. That the important word is distance. Okay? And you can't have a negative distance. Okay. With that in mind, we're going to do just a little bit of a solving with it to make sure you know how to do that. Okay, perfect. So if I say, what's the absolute value of x minus 3 equal to 1, this is now a problem that we have to solve for. We have to find out what values of x make it so that when you do this operation, you get the number 1. Okay? Now, it's important that we have this 2 scenarios. Okay? Absolute value has 2 sides. Okay? So you need to have one case where it's x minus 3 is greater than 0, and you have to have a case where x minus 3 is less than 0. So I'm going to work on this. You count the number of units away or a distance. Now I want you to follow along with this problem. I've got an absolute value, and it's alone on the left side, which is great. That's what we want. We're going to make it into 2 cases now. Okay? Where the first case is when it's positive. So we're going to do the first case. That means that x minus 3 is equal to 1. This is case 1. Case 2 is when it's less than 0. So remember from the very top up here, when we have case 2, we have to input the negative of whatever our input is. Okay? So if we do that, we would write the negative of x minus is equal to. Let me know if you have issues with understanding the two cases. Because once you get this far, it's pretty simple to. I feel like your delay is like 30 seconds. Like you're behind the stream a little. Okay. Then this is just the simple algebra. So if we do case 1, we can just add 3 to both sides. So x equals 1 plus 3, so x equals 4. And then we can distribute the negative, so negative x plus 3 equals 1. We can subtract 3 from both sides, so we have negative x equals 1 minus 3, so negative x equals negative 2. Divide by a negative, we get x equals 2. 2 answers. Check to make sure both work. If you plug in 4, you get 1. If you plug in 2, you get negative 1. They both equate to 1. Perfect. Good. Next, I want to see then, since you understand absolute value, I want to double check to make. I guess it's really all about. Hey, Steph. Let's see. Your linear functions and graphs and quadratic functions is not till next week. Possibly factoring. Factoring is going to come up a lot. So I'm wondering if you are good with factoring. Doesn't look like it's too much into your curriculum. So let's double check your factoring. If I have x squared minus 9, what does that factor into? What are you doing, Steph? I see you. Yeah, no worries. Okay, Lisa, are you just about ready to continue? Okay. So, factoring. Can you tell me what this factors into? Do you know much about I'm going to take that as you probably don't know. No. Okay. So, I think we're going to have to go through some factoring. Let's do that. We're going to start a new page and we're going to go through some factoring. So, factoring is breaking up something into its multiplication components. So, for example, if I had the number 6, if we wanted to factor 6 into its prime factors, well, what multiplies to get you 6? Well, 2 times 3 gets you 6. 6 is 3. So 6, 2 times 3. Those are its factors. If we have a number like x squared plus x, and we want to factor that, we would look for what's in these two terms that are the same, So this would be starting with a greatest common. Okay, greatest common factor. Now we have two terms, and we want to factor out what's in both of them. In x squared and x, well, there's an x in both of them. So that's what we're going to take out. We're going to take out an x. If we take out an x, then we have to leave inside the parentheses what we need so that if we multiply it back in, we get what we started with, plus x. So if we have the x squared plus x, we need to be able to multiply the x back in to get what we started with. So we would have an x plus 1. Because if we multiply the x back in, you get your plus 1, right? X times x is x squared. X times 1 is x. So there we go. We factor. This is in factored. I'm pretty sure you're okay with the greatest common factor. The next thing we're going to talk about is where it's not a greatest common factor, but breaking it up into two separate numbers that it will multiply to give you. So for example, x squared plus 2x, x squared plus 2x plus 1. Not do the same. 5x plus 6. So we want to factor this number. So this is a quadratic function. Now we can factor this two ways. We can... It's two ways, but it's the same way, just two different ways. I know that sounds weird, but bear with me. Normally, you would start with the greatest common factor. There is none, so we don't need it. Okay. Then we need two numbers. I'm going to call them A and B. I'll write it this way. We need two numbers. A and B, such that A times B is our last number, 6. And A plus B is this middle number, 5. Okay? Are you good with understanding where these numbers come from? So then these two numbers, A and B, well, they're pretty easy to figure out. A times B is 6, well, 2 times 3 gives you 6, and 2 plus 3 gives you 5, so 2 and 3. Then there's two things we can do. One's like a shortcut, and one's like a regular long way that'll just... Let's do the long way first. We've got x squared. We're going to break up this 5 into 2 plus 3. Because those are the two numbers we found. So now 5 is 2x plus 3x plus 6. Okay? That 5x from before, it's just broken down into 2 plus 3. Good so far? After that, we can then group them. So let's just quickly do that. Got x squared plus 2x and 3x plus 6. See if you can refer. That's fine. So just take a look here. We're gonna break this 5x from our original question and break it into a 2x plus 3x. Then we're going to group them with the first two terms and the second two terms. You can see here in this first part, just like our original factoring thing, we've got a greatest common factor now. It's going to be an x. We'll take out an x. We'll be left with an x2. And then in the second one, we've got a 3. We can take out a 3. So 3 plus 2. Cool. So now we can do that greatest common factor thing again. We've got this x plus 2 and this x plus 2. We can take that out as one single factor. Okay? Since it's common in both these terms that are separated by a plus sign. So if we do that, then we'd have an x plus 2 taken out. But then we also have what's left, which is this x, this 3. So that would be multiplied by x 3. So our original equation, x squared plus 5x plus 6, in factored form is x plus 2 and x plus 3. Okay. There's one more thing you can do with these. If there's nothing like that we had to do with this greatest common factor, we knew what it was going to turn into when we found the two numbers. 2 and 3. That's just like the quick short. X plus 2 and x plus 3. Now, are you ready for the next? I'm going to give you actually like a kind of a list. Things that I don't have to go through, but it's good for you to have available. So just like for notes reason. So I made a post a little while ago that's got a blackboard on front and it says cheat sheets. If you can have that handy, that'll probably save your life a lot. Because this these cheat sheets that I made, is all the like formulas that you need for like basic algebra. Especially for like notation and stuff like that. I don't have any printable versions of them, but what I can do is make print. But so on my Instagram, so just like you found me on my Instagram page, it's my fourth last page or post. It's the last of the Blackboard ones. It has cheat sheets on the front. So the arithmetic operations, exponents and radicals, factoring special polynomials in the binomial theorem is what we need like the most for you for now. I think even like when you come to quadratic functions, like you will actually go through those formulas, especially the last one there, quadratic formula. Perfect. So let me know what you think. From what you see on there, is there anything you want to go through? Yeah, you can print it. It's just that the Instagram posts are not that great of a size. Like they won't come out good. These pages that I have here that I send you are 8.5 by 11 pieces, so they print out perfectly. And if you go to the Discord server, I have a few printable sheets already up. I should. So, out of in this cheat sheet, is there some of these that you want to go through? Kind of like name the title. Okay. Let's do just a little bit of discussion then on like the factoring part. This is like the second page. Factoring special polynomials in the binary. Because this is like those top 6 are what's going to be like most common for you. So, not to worry. It's all about kind of recognizing these numbers, so don't worry too much. Like, for example, this first one, this x squared minus y squared is x minus y, x plus y. It's literally saying if you have two squared numbers that are subtracted from each other, their factored form is x minus y and x plus y. So, for example, we could have like x squared x squared minus 9. So like our original question I asked you, we see we have this number x that's squared, and we have 9. Well, 9 is 3 times 3, so 3 squared. Which means in factored form, we would have this x, so x, and we'd have this 3, so x minus 3, and then we'd have this x plus. And that's just like the simple factored form. You can do this with other things as well. So I could give you a number that looks way more crazy and way more complicated, but it's just as simple. So like 121 y to the power of 4z squared minus 144 x squared. This looks extremely complicated, but in factored form, or using our difference of squares, it's actually pretty simple. 121 is the same as 11 squared. Y to the power of 4 is the same as y squared, and z squared. This one here would be like a minus, well, 144 is the same as 12, and that would be an x squared. So again, you just use our formula. Our whole thing is this 11y squared and z. So 11 y squared z. And then following our formula, minus 12x. And then again, 7y squared z plus 12x. It's just simple. So can you kind of see and like visualize about using this difference of squares factoring method? Brilliant. Gorgeous. Now, since you have that down, the other ones aren't too difficult. For example, the x cubed plus y cubed. Well, if you look at the formula we've got x plus y. Then we've got x squared minus xy plus y squared. This is our formula. Now, if we have terms to plug in. So let's say this is 8 plus 27z cubed. Yeah, let's do that. If this is what you have and you need to factor that, you can see you've got this sum of cubes. 8 is 2 cubed. 27 is 3 cubed and z. So now just follow your formula. Well, don't forget the z's. You write 2 plus z. So yeah, let's see what you got typed in here. I want you to finish filling out that formula. Two squared, good. Good, good. Keep it going. No, no, don't worry. Keep going. You got it. But wait, remember, the formula has this x times y. We have this 2 and 3z. That's why I put them in blue. But they're a little bit more visual for you. X is 2, and our y is our 3z. So fill it out for us. So this is 2, so 2 times 3z, which would be 6z. And then you'd have the last one. I can write this again just down, so then the last one will be 3z. So it helps if you can like write down each term before you even like do the string or anything like that. We've got 2 plus 3z. 2 squared is 4. 2 times 3 is 6, so minus 6z. And then we'll have 3 squared and z squared, so that's plus 9z. It's not too bad though. So the whole reason I wanted to write it in blue is so that you see the numbers more. And if you can see the numbers, you can input them into the formula a lot easier. So like right here, I just say that x is 2. X is 2. This is y, so y is z. Then all you have to do is literally just replace the numbers, replace the letters in your formula with these values, and you're done. Okay. This is kind of like the understanding of how to use these formulas. Got the binomial theorem on there. I've got the factoring special polynomials on there. It's all the same idea. You just have to just recognize them, figure out which is like what number, and then plug it into your formula and you got it. It is a lot of just kind of recognizing and seeing. There's not too much more to it. Kind of like basic. This is step 1. This is 2. Understanding comes a little bit later. You don't go too far because you're still new in your class. Oh, let's see what else I can go through. Do you have your course topic list, right? You gave me some of the weeks. I want to know if there's a few things that get covered and that don't get covered. Like, do you go through trig function? Do you go through like sine, cosine, and trig function, trigonometric? I mean, like for later on down the line, because you've got like 8 weeks of it, right? I'm just a bit curious, kind of wanting to know like what you're expected to know. I think the only other thing we should really talk about is maybe just exponent rules, which is hilarious because I have another kid that wants help around in half an hour. that wants to go through exponent rules. So I think maybe like a good idea would be exponent rules. No, don't worry. So like the first one was the exponents and radicals. That would be a good thing as well to do. So I just kind of want to like know what other things I can cater for you. So if you look at the post again when it came to the cheat sheet, exponents and radicals, do you understand anything that's written there? Okay. If you don't understand what's written for exponents and radicals, then we should go through that. That's just kind of like a basic understanding, and it's mostly just notation, so you don't have to worry too much about understanding, just kind of seeing. So I'll start a new page again for this. Exponents. First thing is like powers. You know that 2 to the power of 2 is 4, right? Pretty understandable. But in terms of like visualizing it, you know that 2 times 2 is 2 squared, right? With that in mind, we can use this idea of exponents. So this exponent how do I want to write? Or degree is kind of like how many of them are multiplied onto each other. Yeah, that's close enough. Well, the number of times a number is multiplied. So like 2 squared is 2 2's, so it would be 2 times 2. 2 power of 3 is 3 of them, so it would be 2 times 2 times 2. 3. 3 2's. If we have a number like x squared, that's the same as saying there's 2 x's that are multiplied onto each other. So x, x. Okay? For the first idea that we go through is this x to the power of m and x to the power of n that are multiplied onto each other. So this is like just a straight up multiply. They have the same base. So when we have the same base, we add the exponents, so m plus n. As a true example, so you can see what this means, let's say we have a number like x squared times x to the power of 3. We can write this in 2 ways. We're going to write it in a long way first, so you can see what we mean. And x squared is 2 x's, right? So that's x times x. X cubed is 3 x's, so that's x times x times x. So here's your 2, here's your 3. And we want to find out what that total number is. Well, there's 5 of them now. 1, 2, 3, 4, 5. That's x to the power of 5. So in truth, if they are multiplied onto each other, you just add the exponent. Does this make sense to you? Okay, so this is why we're going through this, because you were thinking to multiply the exponents. That's not quite right. We will get there. But this is what happens. This is that main key feature. That's why I would write this x squared as x times x. So then x squared times x cubed is you just multiply each of the numbers out. So you add all the exponents together. There's 5 of them. Okay. Another one would be the next part would be the division. So if I have a number x squared and I divide it by x, in truth, it's the same as x squared minus 1 in exponents, so that we would just get an x. We can show this with a few ways. You know already by the idea of just like division. You have 4 divided by 2. 4 is 2 times 2 over 2. So if you cancel out one of the 2's, you just get a 2 left over. That's the normal standard way. We're doing that same idea with these exponents. We'll have x squared over x, which is the same as x times x over x. Well, yeah, I can hold on. We can cancel out the top and the bottom, and we just get an x left at the top. So let me know when you're ready to continue. Okay. So when we're talking about division, you already know about canceling things out. Just like with this example of 4 divided by 2. You know that 4 divided by 2 is 2. So here I just showed you why. You break 4 into its prime factors, the 2's cancel out, and you're left with 2 over. It's the same idea with the exponents. This top one is to the power of 2. This bottom one, there's only one of them. So we can write it as a subtraction of exponents. Division, we are subtracting exponents. So x squared over x is the same as x to the power of 2 minus 1 x. Because you don't write a 1 in the exponent if you don't have to. So with the multiplication and the division, do you understand how one becomes a adding exponent and one becomes the minus of exponents? Great. This is exactly what we're trying to go through, because this right here is just kind of like an understanding, because you're going to use this all the time. And if you just understand how it works, there's not much to memorizing. Anyway. The next one is like we were already talking about, where you would multiply the exponent. So if I had a number like 2 squared to the power of 2, okay? Well, we can do like an order of operation things. We'll do the inside first. This would be 4, and then the parentheses is still squared, right? And what's 4 squared? We get 16. Okay? Very, very simple and standard, right? If we wanted to leave it so that it's the same base, because that's what we're going to work with, we would be multiplying the exponents. Okay? So this is 2 squared is 2 times up to the power of 2 times 2, which is 2 to the power of 4. 2 to the power of 4 is 16, so that's done. Another way I could write this to be a little bit more visual for you is just the same as we did with the x squared. We could write this as 2 squared times 2 squared. Okay, because there's 2 of them, 2 squared times 2 squared. Then, since they're the same, we can have these same exponents added together, which is 2 to the 2 plus 2, 2 to the 4, which is 16. This is just a coincidence because I used the 2's, but it would still make sense if I had like different numbers to the power of 3. So for this, if we have a number x with some exponent, call it a, and that's raised to another exponent, let b, it's just the multiplication of exponents, x to the a, b. Okay, those are just like some regular positive whole number exponents. The next stuff we get into is like a negative exponent or like a radical fraction. So these first 3, are you okay with? Perfect. A good start. The next are actually pretty simple. So don't worry too much. This next one here is literally just kind of like a definition. If we have a number, here, I'll do it in black. If I have a number x to a negative exponent, all a negative exponent really means is that the number itself is on the wrong side of a division line. So what that means is, since there's nothing written here, this is just 1 over x to the power of a. If I had 2 to the power of negative 1, that would be the same as 1 over 2. If I had 3x to the negative 1, that's the same as saying it's still just a 3, because the 3 doesn't have a negative exponent, over x. Are you okay with a negative exponent definition? Glorious, great, fantastic. Next one's pretty simple. This one, you only have to watch out for x, y to the power of n. This is a multiplication. Everything inside the parentheses is multiplied, okay? If there's a plus sign, then it's not going to be the same, okay? Even if there's a minus sign or anything like that, not the same. X, y to the power of n is the same as x to the power of n, y to the power. This one, not x to n plus. Just not. Just no. Okay? We could think of this in like 2 different number way if we want. So a quick example would be like 2x squared. We would just write 2x twice, remember? So that's like 2x times 2x. So since order doesn't matter, 2 times 2 is 4. And we'd have an x squared, which is the same as 2 squared and x. See how they're the same? Like this is pretty awesome for you because it's not too bad and pretty straightforward. And I think this is really all we need to go through for you, for like the last little bit. There will be other things that come up eventually, but you'll let me know when they do, right? Not to worry. I'm sure you've had like your fill of math for today too, anyways. Since this is pretty much the same, x over y to the power of n, x to the power of n over y to the power of n. Pretty much the same thing. It's just one's a division. Same thing. Not to worry about. The other thing is just kind of an idea of what a radical is. And this is straightforward. You know what a square root is. So if I say the square root of 4, you know that that's 2. Okay. Square root by definition, or nth root, or cube root, whatever, is a fractional exponent. So square root is like having a little 2 in here. So the square root of x is the same as x to the 1/2. Okay? Or the nth root of x is the same as x to the 1. If it was like an x squared or cubed or like some kind of number that isn't the same. So like what's the cubed root of x squared? Well, remember this 2 is like the squared. It's the big number. So it would be like x squared. And this whole thing is to the power of 1/3. So that is x to the 2 over 3. Just like we did before. And then all the other formulas are straightforward. The same thing that we've done already. Is now it's just that you're using a fractional exponent. So how do you feel about this so far? How do you feel about everything that we've done today? Needs to sink in. Do you want like some problems to do? Like what's like you have a textbook, I imagine. Like what's in your textbook? What kind of work can you do? Because most of the time it is really just you do the work. What I could do, this is an interesting, I could make, these sheets are printable. I could make some problem sheets. What can I do to help you understand? Because that's basically what I'm here for. I'm here to help people understand. Email? Like, you want me to email stuff to you? What I do is I just post it in the Discord and you can take it whenever you need. So, like, originally I had you join that channel, right? That channel, that Brains Math Tutor channel, you'll notice how it says in there text channels, general, post questions, welcome to server, Instagram posts, YouTube links, printable sheets, and then there's some voice channels that people can join. I post all that stuff in there and you can download them straight from there. I try and have as little things as possible so that people don't have to give me personal information. Right? That's as nice as way to be. It's like I don't want to have to like force people to give me their email. Simple as possible, like no pressure. If you want it, you want it. If you don't want it, you don't want it. No big deal. What what would you like for me to do for you? Yeah, I don't know why it is for you. We can sort that out. Okay. Okay. There's anything else? Okay. Work on your assignment. If you have any troubles, let me know. I'm gonna still be live on here for a little while, I know for sure. Yeah. Whenever you need help, just let me know. Send me a message, whatever. If it's something quick that I can just like take a picture of my screen here and send it on Instagram, then I'll do it. I'll respond when I can. We can set up more times. Anything. Very welcome. Very, very welcome. If you know other people that want help, just let them know that this is what I do too. I'm still super small and I don't make any money yet, but if I can get enough people, I'll make a little bit of money. It's funny, the Instagram to YouTube doesn't transfer very well. So I'm gonna try sending you more pages. See what happens with it. Okay? I'm gonna send you some notes that we did here. That one. So you let me know if these pages work for you. Might just be that I have to send them like one at a time so that they don't fail on you. That's good. Glad you have these notes. Cool. Very good. Very, very good. Uh, let's see. Buddy said he's gonna be late for an hour, so I've got an hour. I think I'll do is sort out what to make for a next post while we wait. There's that. Okay. Gonna be late for an hour. Okay. Then I think this is good for now, and we'll be back in an hour.